Who the man? Who the man? Who the man? Who the man?
Plus sign, multiply, subtract, and divide. Get math in your mind, then you'll see your dollars rise. Teachers, have your kids play video games, cause it helps to get the math facts into the brain. Simple and plain, we educate with minimal strain. Have fun, everybody now, isn't it great? Try some long division today, we just give it away. No time limits, you can...
All right, here we are back, video 36. We're
It
gonna go,
is us and they are them.
yes, and we're going to continue with linear regression, mostly using R kind of in a real term context today.
We're talking real world math here.
Yes, real world.
Actually, Mr.
So,
Lewis, that's one good thing about stats. You hardly ever hear, when will we ever use this? Because all the problems are like real world problems.
that's true. All right, so our first one, or the one we are going to do with you, focuses on little children in lunchtime. Okay, so people collected data. I'm not really sure why they would want this, but how long children remain at a lunch table to predict how much they will eat. So the table gives 20 toddlers observed over several months at a nursery school. Time is the average number of minutes the child spent at the table, and calories was the average number that the child consumed. Okay?
Wait, it's kind of weird. So it's a negative association.
Yes, so
So what they found is the more time they spent at the table, the fewer calories.
that's true.
You think the more time they spent there, the more they would eat or whatever?
Yeah, you would think that.
But maybe when they
yes,
took their
you're right.
time, they consumed less calories. Anyway, all right.
So, what we want to do, we want to find the correlation for this data. So whenever you see the correlation thing, that's our term for...
No, wait, back up a minute. I think those little kids should use this data to say they should have a longer lunch period. If they're really sharp and had AP skills, they would present this to the principal and say, we should have a full hour for lunch.
Sure.
This is why you should do stats in nursery school. Empower those little guys.
Anyway, whenever you see the correlation, that's our term for we want R. Okay, so what we've kind of already done, we've put those things in our calculator. So in our L1, L2, and then we went to stat, linear regression, to find our R. And Mr. Miller, what was our R correlation for this?
What if I told you I lost it?
I would be upset.
Okay, it's negative 0.649. It's almost negative 0.65.
Negative 0.64. Okay. So that would mean, like Mr. Miller said, we had a negative correlation, which means our line is sloping downward.
Yeah, and moderate. You know,
Yes.
not really strong. Well, 0.64 is not horrible, but I wouldn't consider it strong.
Okay, well what happens if we converted the time in hours instead of minutes? You see we have minutes, what if we made those hours?
So that's something we have to understand is some properties about the correlation coefficient. Like if we change the data somehow, what would affect R? Like if we switch the X and Y and just graph it the other way, would it change? So we want to start talking about those things. So this one is what if we change the units? So if we converted the time to hours, we'd pretty much just be changing the scale on the x-axis. Right. So that 25 minutes would be, how much of an hour is that?
I don't know, like
25
0.4.
divided by 60, 0.42. And then of course 30 minutes is 0.5
0.5
hours, and 35 divided by 60 is 0.58. And 40 is 2/3, so that'd be 0.67. So if we converted the time from minutes to hours, we'd just divide all the time by 60.
Yeah.
So it changes the data values, but it actually doesn't change the z-scores, which is what we use to compute R.
Right.
So
yeah, it doesn't really change any part of our line, just what we're looking at.
So it might stretch the graph out, like we just changed the scale. So instead of 25, 30, 35, 40, if we change the hours, it would be 0.42, 0.5, 0.58. Even if you stretch that out and use a different scale, it doesn't affect how strong the pattern is. And that's the idea. Yes. Changing the units doesn't change the strength of the pattern.
Correct.
Even if like stretch it out horizontally or we use a different scale. So changing the units has no effect on the value of R.
No, it does not.
Okay.
All right.
We got this one property we got to know.
All right. So then we get to Oh, the fun of writing in stats. So write a sentence or two explaining why this correlation means to the data. Well, it is hard to write in this pen. I don't know if I'm going to go a whole sentence or two.
Let's make
But-
him do it. So you can do it.
All right.
Because, well, let's
See.
see. At least we can talk it out first.
Yes.
So because it was a negative association, it simply
Mhm.
means that the data shows that the more time they spent at the table, there was a tendency to consume fewer calories. Now, this is an association or pattern. What I'm going to talk about in a minute. This does not say cause and effect.
Yes.
It doesn't. Longer time doesn't force the kid to consume fewer calories.
Right.
It was
More
a
time spent
trend
at the
or a
table.
pattern.
Um,
Meant fewer calories.
and yeah, that's what I meant. Trying to word it. Not bad.
Okay,
Right.
that's what we observed. Now, the next question says, it is clear from, or one analyst concluded, it is clear from this correlation that toddlers who spend more time at the table eat less. Evidently, something about being at the table causes them to lose their appetites. Could you underline, evidently something being at the table causes them to
Yes.
lose their appetites? Yeah, maybe they're looking at the food and thinking, no way. But this is a key thing. You can't claim that one variable causes another. That is a very strong statement. You would have to do an experiment. You'd have to
Yes.
eliminate all of the other possible things that could be affecting their appetite besides time. So maybe the food was just gross. I don't know.
Right. We don't really know.
Yeah, so even though we know there was an association, there was a pattern, we don't know what causes what. So any statement about this implying that something causes it is automatically false. We can't conclude that.
Right.
So that's going to come up again and again. And you just got to remember, even though there's an association, that doesn't mean one causes the other.
Right. Can't conclude causation.
Cause, you can just say cause and effect. Very good.
Bingo.
All right, that was actually a good problem.
Yeah, I liked it.
So when those kids go to the principal, he could turn around and say, yeah, that was the pattern, but you haven't proved to me that it was more time that caused the fewer calories.
That's true.
So if they're both good at their stats, this could be a good argument. All right.
All right. Now it's your guys' turn. All right. So it's a lot of words, so we'll kind of walk you through it. Okay. Here we have the description of our problem, in which we're dealing with the Minnesota Department of Transportation and their weigh-in motion scale. Okay, so as the truck kind of comes through, this is how much the truck weighs while they're moving. It's how much they're weighing while they're just sitting there.
Yeah, so they invented a device so the truck doesn't have to stop.
Right.
So they don't have to slow down the truck. They could just go through the device and keep going. Kind of like the iPass on the tollways. You don't have to stop and put the coins anymore. You just
Right.
drive through and it bills you.
Which is nice.
So kind of like this. So the truck doesn't really have to stop and wait. You can just kind of go through the device and keep going. So they compared weight and motion. That's using the new device with the old school way. Static means it's not moving. That the truck parks and they weigh it and then it goes on.
Right.
So they're trying to. I would hope there's a relationship.
I
If it
would
weighs
too.
a lot in motion, it should weigh a lot when it's not moving.
So remember to put these in your lists and then make the scatter plot for it. And then do our normal describe direction, form, strength. If there's an unusual feature as well, might want to put that in. Write a few sentences telling us what the plot says.
What do they mean by
Okay.
that sentence in parentheses? See that? There's
Sentence.
note. The sentences should be about weighing trucks, not about scatter plots.
Right. So we don't want to don't be like, oh, the dots are going downward, and that would mean that.
Yeah, or strong. We want to talk about the association between static weight and weight in motion.
Right. Make sure it's about the problem, not your graph. Okay.
Okay.
Find the correlation. So remember that's R that we're finding there.
Okay. If the trucks were weighed in kilograms, how would this change the correlation? You could actually try it To change to kilograms, you could divide all of those by 2.2 and find the correlation again. But if you think back what we said in the video about changing units, you should be able to figure out E.
Yeah.
And then F, we talked about that, so don't fall for that.
Right. And I think that's it.
All right.
All right.
Sounds good.
Yep. See you guys tomorrow.